Hello, mathematicians. So here we go. We are in day 3 of Unit 6, and our essential questions, we're going to be talking about the fundamental theorem of calculus with accumulation functions, and we are going to interpret the behavior of these functions involving some area. So this is our essential questions, so we will go back over this, make sure we've got that down in class. I'm going to move my little fun guy. Okay, so here we go. This is the graph right here of f of t. And what I'm going to do is I'm going to define g of x as the integral from -1 up to x of f of t. And here's f of t. So for instance, if I went from -1 to 0 right here, then I would be looking at this area, okay? Because an integral is asking for area. So what I want us to do is to find the values going on for these x values. That's a line. Okay, so we just did the 1 here. We just kind of looked about, no, we just did the 0. So if I did the 0, let's see what this area would be. So that is a triangle, 1/2 base times height, and I get out an area of 1/2 here at 0. An easy one to plug in is -1. -1 to 1 hasn't accumulated anything, so we know straight away that that's going to be 0. Let's do one where it is flipped. So -2. So now this is in reverse order. This is where I start and this is where I end. We need to flip it because -2 is smaller. So when I flip, remember that we have to negate our answer. So now I want to look from -2 to 1, and that would be a -1/2, but we want to negate our area, so it's a -1/2, which would be a +1/2. So I know here at -2, I have a +1/2. So I want you to pause and see if you can go ahead and get some of these areas, and then unpause after you have tried, and see if you agree with what I write. And if you have any questions with those, let me know. Okay, so we're going to go back to this graph again of this f of t. And it says that I want to indicate all the relative extrema, points of inflection, all of that fun stuff we're going to be looking for. So we're going to use this graph to help me out. So here, if I can see what we had going on, let me go backwards really quick so I can get that. So at -3, where we had that, we knew that our function was at 1. At -2, we knew our function was at 1/2. At -1, we were at 0. 0, we were at 1/2. 1, we were at 2. So I'm just filling in from the chart that we just had. 2, we were at 4. 3, we were at 5. 4, we were at 4. 5, we were at 2. 6, 1/2. And 7 was at 0. So I'm going to just kind of try to make this connection going on. Of what a possible graph could look like for g of x. Because that's the integral, we go backwards. So now if I said, well, what's the derivative of g of x? We know that we would go forward to f of x, which we can see the graph. Okay? We'll get to that more with the second fundamental theorem of calculus. So here it says, on what interval is the graph of g of x increasing, or intervals? So g of x is increasing starting here at -1 and going all the way until 3. And we knew that should be the case because that is where the derivative of g of x, which is that f of x, is positive. And here we can see that connection again. So on what intervals is the graph of g of x decreasing? See if you get the same as me. I am going to say -3 to -1, decreasing, and union that with 3 to 7. And I could see that that would be the case because that's where f of t is below the x-axis, aka where the derivative is negative. Okay, where is the graph of g of x concave up? That's going to be where f of t is increasing. So look at your graph and find where f of t is increasing and see if you agree that that was -2 until 1 and then 5 until 7. So concave up, remember, is where I'm smiling. All right, concave down, that's going to be here where the f of t is decreasing. So f of t was decreasing from -3 to -2 and 2 to 4. So where does the graph have g of x have a local min? That's going to be where f prime goes from negative to positive, and that's going to happen at -1. Where does this have a local max? That's going to be where f prime goes from positive to negative, and that happens at 3. And the points of inflection are going to be where, oh, I put f prime. The derivative, it's g prime. I'm so sorry. G prime, which is f, got my functions confused, goes from the negative to positive there, and where g prime goes from positive to negative. This would be where g prime goes from increasing to decreasing or decreasing to increasing. And let's see, does that happen? That is going to happen at -2. Oh, look, that doesn't really happen anywhere there or there. So it really looks like the only point of inflection is going to be here at -2. Okay. So this next one, these are going to be some graphs. These are the graphs of f of t. And we're going to use these and you'll have to go back and forth to the next page, okay, to answer the questions on the next page. Okay. So here, this first example says the graph of g of x is increasing from 0 to 4. So I want to go see which one of these would let me know that g of x is increasing. And let's see, increasing from 0 to 4 can't be A because 0 to 2 is negative, cannot be B because 2 to 4 is negative, cannot be C. Let's see, cannot be D. E, look at that, we are positive from 0 to 4. Now I know you're like, we're not really positive there, but it doesn't cross through, so we're going to accept it, okay? So that would happen at E. F is all negative there. G is completely positive. Negative switches. J would work, and K would work. So we can see that E, G, J, K would be a true statement for this. That's where the graphs of f are positive, because remember, g prime of x is the f of x. Okay, so let's look at our next one. I want to know where g of x is decreasing on 0 to 4. So decreasing would be the condition we are looking for where f of x is negative on that interval. So on 0 to 4. So where am I completely negative? Oh, here we are on h. We are negative from 0 to 4. Any more? Oh, f, we are negative from 0 to 4. And that is all. So I know that this would be on f and h. Okay? So number 3. The graph of g of x is constant. Okay? So do I have a constant anywhere? Meaning that we're not increasing or decreasing. So we would be 0 on the entire interval from 0 to 4. So, man, if that line was here, that would have worked, but it's not. So I do not see that anywhere. So this, none of those graphs would make that statement true. Okay, next one. Looking for where g of x is concave up. That would be where f prime is increasing on that interval. So can you go find the graphs where f prime is increasing on the interval from 0 to 4? Pause me and then come back. So I got ACIJ. Okay, here we go where g of x is concave down. That's going to be, guys, I'm so sorry, not f prime, f, which is g prime. That's twice. I've already done that. I'm crazy. I tell you, I'm crazy. Okay, so this is going to be where f, which is g prime, if we are concave down, is decreasing. So go find those graphs where f is decreasing, aka where g prime is decreasing on that whole interval. And did you pick E and D? That's what I picked too. Okay, so let's look at the next one. So I want a local max at 2. So that means that f of x goes, which is g prime again, goes from positive to negative at x equals 2. So go find the graphs where that would happen. I'm going to give you a hint. There's 2 of them. Find them. And I got B and D. Number 7, now we want a local min at 2. So that is where g prime, which is f of x, goes from negative to positive at the x equals 2. There's 4 of these, A, C, I, and L. Okay, so let's see if you guys can finish 8, 9, 10, 11, 12. Pause, and then when you're ready, come back and check. Okay, 10, F and G is increasing on 0 to 2, and F is decreasing on 2 to 4, and then 11 is a lot. E, F, G, H, J, K. Basically, F never crosses the x-axis on 0 to 4. That's what I wrote. You may have wrote something similar. And 12 has a ton of as well. So A, B, C, D, I, J, K, because F never has a local extrema. Even better, F never goes negative to, or increasing to decreasing, or decreasing to increasing on that interval. I like that one better. Okay, hopefully you did good. Okay, check your understanding, see how you do. We're going to talk about if these are true or false. So true or false. If I have this guy going on right here, is this a true or a false statement? Well, when I just have the number to the x and I'm taking the derivative, this is a true statement. Okay, so let's look at this. If f is increasing, and remember f is g prime, so it says f is increasing, aka g prime is increasing, then what do you know about g? We don't know that it's increasing, okay? We know that it is concave up. So if the derivative is increasing, the original is concave up. Okay, let's look at this. So again, when it's talking about f, it's talking about g prime. So if g prime is increasing, oh, sorry, I forgot to say false here. Okay, so if g prime is increasing, does that mean that g is concave up? No, it means that g is increasing. So derivative is positive, original is increasing. There's just little things. I don't know if that helps. So g prime is greater than 0, g is increasing, less than 0, decreasing, increasing, concave up, decreasing, concave down. That one is false. Okay, next one. If f changes sign, so again, that's basically g prime, changes sign from positive to negative, then does g have a point of inflection? No, g would have a relative max. False. And if f has a local minimum, aka if the first derivative has a local minimum, it is going from decreasing to increasing, then g has a point of inflection. That is a true statement. So the next one we're going to do is one I want you to try on your own. Basically accumulating the area, but it's all straight lines or circles, stuff you can do with using geometry. And I want you to see if you can get D. All right. Next one, here is our beautiful graph of F. And remember now, G prime is F. So this is actually the graph of G prime. And I always just cross it out and make that connection. And then I can use what we learned back in the last unit. And it's not so bad at all. Okay? So this is a fill in the blank for these statements. Where is G decreasing? Well, I know G is decreasing when G prime is less than 0. So where is our G prime up here less than 0? That would be from negative 10 until 4 and from 7 to 9. G is concave up when G prime is increasing. So where is that graph increasing? I got negative 10 to -2, 0 to 2, and 8 to 10. Here it says G is concave down. Well, G would be concave down when G prime is decreasing. And I got 3 intervals again for that. -2 to 0, 2 to 4, and 6 to 8. So when I look up there, I can see that from -2 to 0, from 6 to 8, oh, I skipped one, and from 2 to 4, those are the only places where this graph is decreasing, and I am wrong. I almost left off -10 to -8. I'm also decreasing. Oh, crazy. -10 to -8. There's actually 5. Oh, I'm going to write that down. I messed it up on my notes. What? Okay. So what was that? -10 to -8. All right. So then we said that the increasing was from -8 to -2. 0 to 2, and 8 to 10. So look at that. I'm so glad that we looked ahead. Did anybody else see that that should have been a -8? Oh, holy moly. Okay. Math. Then the last page is just going to be some extra review if you need it. Okay. Just kind of doing a little bit more with these and making sure you really have this down. All right. Good job.